Hello, everyone. This is James with Team Save the Dislikes. I'm here with Jenna and our partner, Shashank. So we're discovering the idea between dislike ratios on how to predict that based on the other features of YouTube data, since YouTube has removed the dislike count. So since our last update, where we had 300 million rows of data in a database, we've had some setbacks, but we were able to solve that. So we've completely rewritten the SQL commands and all the scripts related to importing the data. We've been able to process those into Parquet files and then into Postgres. And now also some pre-filtering steps on that. So we've reduced it from 300 million to 80 million of solid data that we can run SQL commands with indexes to get some functions running with very efficient progress. And that's allowed us to export some useful CSV files for our research. So we've been able to sort the data set, all 80 million, and extract the top 500,000 most disliked, as well as the top 500,000 liked rows of data, videos based on their dislike to like ratio. And we've also been able to export a 1% random sample of the data, which is actually still quite large at 800,000 rows, roughly, as well as some mini CSV files that will help in our research. So that will kind of be at the foundation of being able to analyze the data set. And in the meantime, Sashaank has been working on a web app that we'll be working on at the end. So he's built this web app where the idea here is that we're going to be able to put in a YouTuber link or video ID, submit to the service. It's going to use the requests and beautiful soup libraries to then extract the data, basically scrape it live from the video, get all the metadata, the title, the views, the description. And all of these features will eventually be used in our model in the future to predict YouTube, the dislike to like ratio, and most likely categorize it into idea if it's a problematic video or not. This web app will also allow us to have a dashboard at the top where we'll be able to have like a live interactive dashboard, most likely using Plotly, to show like interactivity with our research data, as well as an about section where we might put some of our indexes or something, including our blog and our steps towards to do it. And so that's for that part. And I would like to hand it off to Jenna to talk about the initial research and analysis part.
Thanks, James. So to kind of start the week off, what I had originally started looking into was deciding what type of sentiment analysis we wanted to use for our data sets, for the comments that we're going to collect later, as well as the descriptions that are included in the video. So to kind of kick that off, what I really started to do was just, come through the data set, get a better understanding, did a little bit of normalization to try to run a PCA. I had attempted to try using TextBlob and found it rather inefficient. In our concluding data set, it just did not run as fast, and the results didn't necessarily produce for us what we wanted. So Shashaank had recommended using Vader. That was something we tried instead, and that's ultimately what we're going to go forward using. So again, this is just my principal component analysis chart so we can start getting an understanding of features that we plan to incorporate down the road. So this was run on the mini file. We then tested it again on the feature of 100,000 files and on the 500,000, and we're yet to test it on the 800,000 that are coming up. We likely will need to upgrade our Google Colab just to make sure we can better accommodate things going down the road as we're working with such a large data set. But ultimately, now that we've been able to pick our different features and get an understanding of our data set, we're kind of moving towards really developing the descriptive analytics and modeling for the remainder of our data set. So we've noticed we have significantly more continuous variables, and we instead want to recategorize our data to make sure that we are producing a non-continuous variable for our models. Ultimately, the question that we're trying to answer is, would a more advanced, more complex model with less data produce a better result than a simple model with a lot of data? So that's kind of what we're trying to figure out at this moment. And we really are open to maybe feedback on that point and what may make the most sense there. So please, any advice that you could pass along for the time being. Other than that, that's our update for now. Thank you very much.